Okay, so hello everybody. We're going to be talking about vector story problems today. These are actually a lot more simple than you would probably guess. These are just kind of like baby vectors and baby situations to begin with. Obviously, as you get more into it, it's going to get more complex, but these are just very basic situations. So, I'll just kind of dive right into it. We're going to like model the situations, and then some of the math is going to be pretty simple. Some of it might require the Pythagorean theorem, but that's as like hard as it's going to be. So when we look at this, suppose a plane is traveling east at 110 miles per hour. Okay, so east would be right there. It's going to the right, and it's going 110 miles per hour. And then it's got a headwind of 20 kilometers. Sorry, talking about kilometers, not miles. So kilometers and a headwind. You're talking about a headwind that's like going against you, right? So we've got a headwind of 20 kilometers per mile. Okay? And it wants me to model the situation, which is literally what I did. That's the model right there. Okay? And then it wants me to find the resulting speed of the plane. So if we have two forces going against each other, you would just subtract them. So like here, we would just have like this vector minus this vector, which is 110 minus 20, which is just going to be 90 kilometers per hour. Learn to write kilometers per hour. Okay, there you go. That's your answer. Pretty tough, right? Again, these are going to be pretty simple for a lot of time. Okay, a plane is traveling east at 110 kilometers. Why did we not do miles per hour? Who wrote these? It was me. Sorry. 110 kilometers per hour with a tailwind of 20. So we're going east again, 110 kilometers per hour. And then a tailwind is coming behind you. Okay, so it's going to be behind and it's going to like go the same direction you are, right? So a tailwind of 20. So this is going to be like the difference between a tailwind and a headwind. So tailwind's going to aid you. It's going to add to your kilometers per hour, right? It's going to help you go faster. So all you would do is just add those two things. So 110 plus 20 is 130 kilometers every hour. And that's all you would do, right? Okay. So this time, an airplane flies due west, so going this direction, at 240 kilometers per hour. Okay. At the same time, the wind is blowing south. So we got a southerly wind here. Okay, going at 70 kilometers per hour. Okay. And that is a more realistic representation of it, but just to make it easier for myself and what I'm about to do, I'm going to draw it going down here like 70. Okay? Because all you would technically do in this situation is figure out the length of this line right there. Okay? So this is essentially a Pythagorean theorem problem, right? We've got this squared plus this squared, and then you square root. So to set it up, it would be like 240 squared plus 70 squared, and that's going to equal whatever the vector is squared, right? So 240 squared plus 70 squared is 62,500. And then to get back to what it should be, I'm going to square root that number, and I would get 250. So 250 kilometers per hour would be my answer. So the southerly wind aids in the speed a little bit. But again, if you're traveling 240 miles this way in 70, you're going to have to go a little bit faster to travel that distance. So it makes sense. Okay. And that would be your answer. Again, these aren't tough, right? It's either going to be a subtract, an add, or a Pythagorean theorem. And that's essentially all you're doing today. Like, they're not hard problems. They're pretty easy, actually. And that's all I'm going to do. Okay. If you have any questions, concerns, ask your teacher. We are here to help. We want to help, and I'll see you out there.